Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss some very interesting questions related to principal component analysis. Okay, and all the questions are going to be very helpful for the interview preparation related to machine learning or data science. Okay, right. So without wasting much time, let's start with our first question. And here comes the simple first question. Imagine you are given the following scatter plot between heights and weights. Okay, this one. And these are the four options. Select the angle which will capture maximum variability along a single axis. Okay. Option A 0 degree, option B 45 degree, option C 60 degree, option D 90 degree. All are approximate angle, right? Now pause my video and try to think about the answer. Here I am explaining the correct answer. So no doubt the correct answer is yes, option B. Because you can easily understand that if you consider a line like this and if you project all the data points for which scatter plot is drawn on this particular line, then you will be getting maximum variance. Okay, and in the principal component analysis, the main goal is to find out the line or the alignment of the straight line for which you'll be getting maximum variance if you project all the data on that line, right? So obviously the correct answer is option B. Okay, coming to this question. Consider the following 2D data set. This is the data set scatter plot. Same question like first one, right? Now the question is, which of the following figure corresponds to possible values that PCA may return for U1, that is first principal component, first eigen or first eigenvector. Okay, no need to confuse with first eigenvector. You just consider this as first principal component, right? And you have to check all those which are applicable. And here comes your four options. So now again, pause my video and try to think about the correct answer. Here I am explaining. Okay, so no doubt the correct answers are option A and option C, because you can understand that the line on which if you project the data will be getting maximum variance is this one. Okay, sorry, I have drawn in a wrong way. This one. Okay, now along this line the vector can be defined in this way or this way, right? Both will be indicating same line only, right? So that's why the correct answer are option A and option C. Okay, because see, this vector is pointing to this direction, this vector is pointing to this direction. Both are correct. And the second principal component will be what? The second principal component will be no doubt the orthogonal to the first principal component. So this is my first principal component. This is going to my second principal component, which you can get here. So if you are asked that what is the alignment or vector direction for which you will be getting second maximum variation if you project the data along that direction, so that time the answer could be option B and option D, because this direction our second principal component or in the reverse direction we can see. So right, so I hope you have got the feeling, the idea. Okay, now coming to the next question. So before going ahead, this particular discussion, whatever I have done, you can refer this particular link. I have explained in depth intuition and the proper visualization. Okay, I'll be providing the link also in the description box. You can go ahead and check. Coming to the next question. Which of the following is a responsible way to select the number of principal components K? Okay, that is in principal component, the major aim is what? Dimensionality reduction. Now, how you are going to select that, how much principal components you are going to consider in the reduced space or in the reduced dimension. Okay, and here it is given the hint that recall that n is the dimensionality of the input data and m is the number of input examples. So m is number of rows, n is number of columns. You can understand like this way. Now options are: choose k to be the smallest value so that at least 99% of variance is retained. Option B: choose k to be 99% of m. What is m? M is number of input examples. Okay, and that is k equal to 0.99 into m rounded to nearest integer. So this option is indicating you should choose the k, that is number of principal components, or in the reduced space, what should be the dimension? That should be equal to 0.99 multiplied by number of rows present in our data. Okay. The third option is saying choose K to be the largest value so that at least 99% of variance is written. And option D, use the elbow method. Now, pause my video and try to think about the correct answer. Here, this is only one option correct. Okay, right? So, here I am explaining the correct answer. So, no doubt the correct answer is option A. Choose K to be the smallest value so that at least 99% variance is written. Okay. Obviously, no doubt the option B is wrong because selecting number of dimensions for the reduced space has no relationship with number of records present in our data, right? And here, obviously, so this option will go wrong. Then, choose K to be largest value so that 99% of variance is written, or choose K to be the smallest value so that at least 99% of variance is written. Now, you just think, suppose suppose there are 5 dimensions present in our data, that is this n value is 5, and when you applied PCA, the first principal component is explaining majority part, then the second one, then the third one, then the fourth one, and then the fifth one. Fifth one is explaining minimum one. Okay, now what should you choose? That first one, which is explaining the maximum amount of variance, considering first one and maybe up to second or third one, you should suppose you are getting, using this first thing only, you are getting 99%. Okay. Now, as these rest of the values are quite small, so if you are taking the features from the back side, now suppose you have to consider more number of principal component, and considering all these 4, suppose you are getting 99. So, which one you should choose? Obviously, the first way, where considering only 3 principal components, you are capturing maximum amount of variance, because main target is reduce the dimension, and as well as we need to capture maximum amount of variance. So, K should be small. Okay, suppose within by selecting 2 or 3 principal components from the left side, okay, we are getting this 99% variance. Then we should choose that one. It should not be like that. We need to make the reduced space as high dimension as possible, right? So obviously this option will also go wrong. No doubt the correct answer is option A as a result. Use of elbow method. Now sometimes we use elbow method. I am not telling it is completely wrong, but as you know, like in chemics also, elbow method sometimes might be difficult to interpret and sometimes may lead to wrong interpretation of result. Similarly here, always if it is single option correct, the first option is the best possible answer. Okay. Now coming to the next question. Before going ahead, if you want to refer this video, that is this particular concept in detail, you can refer this particular video, which link I will be providing in the description box. Okay. Now coming to the next question. Which of the following are recommended applications of PCA? Select all that apply. Option A, data visualization. To take 2D data and find a different way of plotting it in 2D. Okay, with K value as 2. K2 means what? In the reduced space, after applying PCA, the dimension should be 2. Okay. Option B, as a replacement for linear regression. Option C, data compression. Okay. Reduce the number of dimensions of your input data xi, which will be used in supervised learning algorithm. That is, use PCA before running your supervised learning algorithm, so that your supervised learning algorithm will run faster, because it has to handle lesser number of input columns or input features. Okay. And the last option is again data compression. Reduce the dimensions of your data so that it takes up less memory or disk space. Okay. Now pause my video and try to think about the correct answer. Here I am explaining the correct one. So obviously, no doubt, this is not going to be the correct answer. Okay. It might happen that we are using PCA to visualize our data, but it is not like that we are taking 2D data and we are applying PCA to visualize our 2D data only. It might happen that that is 10-dimensional data and we are applying PCA, then we are converting to 2 dimension, because human brain can visualize 2D or 3D data, that is lower dimensional data properties. That time we can use data visualization concept for using PCA. But it is not like that. For 2D data visualization, we are using PCA, right? So option A wrong. And PCA is not at all replacement for linear regression. Regression is completely different thing. Dimensionality reduction is completely different thing. So obviously this option is also not going to be the correct one. Now, data compression. Yes, I have shown you that we can apply PCA and then we can use that reduced features for our supervised or unsupervised machine learning algorithm. And obviously it will be faster because that particular machine learning algorithm, whatever you are using, that is unsupervised or supervised, has to handle lesser number of features. Okay, so obviously this answer is correct. And the last one, see, when you are reducing the number of dimensions, then basically the data, overall data volume is reduced. That time it will be easier to accommodate that data in memory. So obviously this option is also going to be correct. The correct options are no doubt option 3 and option 4, right? I hope you are getting the idea what kind of questions can be asked in the interview process and how you can handle this using the theoretical intuition, using the visualization, using the programming part, using the project part, whatever I have discussed in my previous videos, right? Now, coming to the next question. The most popularly used dimensionality reduction algorithm is principal component analysis, PCA. Which of the following is or are true about PCA? Okay, and here comes your options. Option 1, PCA is an unsupervised method. Option 2, it searches for the direction that the data have the largest variance. Point number 3, maximum number of principal components less than equal to number of features. Option D, all principal components are orthogonal to each other. And you have to choose among these options A, B, C, D, E. A option is telling first point and second point are correct. B option is telling first point and third point are correct. C option is telling second point and third point are correct. D option is telling first point, second point, third point are correct. E option is telling first point, second point and fourth option are correct. And F point is telling all are correct. Pause my video, try to think about the correct answer. Here I am explaining. See, PCA is an unsupervised machine learning algorithm, no doubt in that, because we don't require the labels to apply PCA. We simply apply PCA and we get the reduced dimensionality reduction data. Right. So option 1 is correct. Okay. Then it searches for the direction that the data have largest variance. Yes, that's what the intuition or final goal of PCA. So option 2 is also correct. Right. Option 3. Maximum number of principal components less than equal to number of features. Yes, obviously, right? Suppose we are having 5-dimensional data, then we are applying PCA with this particular aim that we want to do dimensionality reduction. So, obviously, number of features in the reduced data or in the output of PCA will be less than equal to 5. Okay? So, basically, principal components will be less than equal to 5. So, option C is also correct. Option 4. All the principal components are orthogonal to each other. This is obviously correct. I have discussed in detail in the first video of my PCA. So option 4 also correct. With all these points correct, so that the correct answer is option A. Okay. If you have predicted this F option, well and good. Congratulations to you, because all these 4 options are basically the major concept of PCA, explaining the whole concept. Okay. All these 4 points are very important. And by mistake, if you have chosen some other option, no issue. You have learned this concept. I hope you will not forget this from next time onwards. Okay? Right. Then, coming to the next question. Suppose we are using dimensionality reduction as pre-processing technique. And that is, instead of using all the features, we reduce the dimension to k dimensions. That is reduced space with PCA. And then we are using, use those PCA projections as our features for machine learning algorithm, right? Which of the following statements are correct? Option A, higher K means more regularization. Option B, higher K means less regularization. Option C, cannot say. Okay, right? Pause my video, try to think about the correct answer. Here I am explaining. So before going ahead with your answer, first you need to know what is regularization. If you recall the linear regression, what we have, why we entered into regression or lasso regression, because we wanted to ensure that our model should not overfit. Okay, so those are regularization techniques. So always for regularization, the aim is our model should not overfit. Okay, the regularization basically controls the overfitting part. Okay, now see, if you take higher k, that means what? That means you are basically preserving maximum amount of information, right? That means you are not that much distorting your original data. Most of the information from your original data is preserved, right? So higher k means that is approximately your original data only, right? So that means there is a possibility that we might get very high accuracy, because when you are applying dimensionality reduction, then we are losing some amount of information. As a result, that much high accuracy we might not get. But suppose you are keeping the number of dimensions in the reduced space also very high, that means you are not basically ignoring much amount of information from original data. You are preserving most of them. So that means there is a possibility that accuracy will be high. That means there is a possibility that that model can be overfitted. So higher k means overfitting, and the aim of the regularization is to reduce overfitting. But higher k means overfitting, right? So higher k means less regularization. That's why overfitting is happening. If it is becoming more regularization, that time overfitting will not happen, right? So the answer is option B. Higher k means less regularization, because higher k means overfitting, and less regularization means there is a possibility of overfitting, because regularization controls overfitting. More regularization means no overfitting, like that. Okay, so correct answer is option B. Okay, now coming to the next question. PCA works better if there is option A, a linear structure in the data. Option 2, if the data lies on a curved surface and not on a flat surface. Option C, if the variables are scaled in the same unit. Pause my video, try to think about the correct answer, and remember this is multiple option correct. Okay, so no doubt the correct answer is going to be option 1 and option 3. Okay, so it is quite obvious that PCA, SVM, all these things you can understand from the intuition itself. It works well if my data is linear structure. Okay, suppose I am having some round shape data, that time projecting that on a particular line to get maximum variance would be a very difficult job, and that's why kernel, PCA, and some higher order concepts are there. Okay, so option 2 is not correct, and option 3, if variables are scaled in same unit. Yes, in PCA this is required. I have already discussed in detail whether feature scaling is required in PCA or not. If you want to know the detailed explanation, you can go through the link given in the description box. Okay, now coming to the next question. What happens when you get features in lower dimensions using PCA? Option 1, the features will still have interpretability. The features will lose interpretability. Option 3, the features must carry all information present in the data. Option D, the features may not carry all information present in the data. Again, this one is multiple option correct. Pause my video, try to think about the correct answer. Here I am explaining. So see, when you are applying PCA, you are getting reduced data, right? So suppose in the original space, higher dimensional space, there was significance for each column. But when you are passing via the system which is applying PCA, then actually in the output side there is no such significance of individual columns. So with respect to the original higher dimensional data, in the reduced space we are losing interpretability of individual columns, right? So the option 2 is correct. And see, when you are reducing the dimension, at least some amount of information you are losing. Obviously, the amount of information after reducing the dimension is not at all equal to the amount of information which was present in the actual data. At least some amount we are losing, right? So obviously option 4 is correct. So the correct options are option 2 and option 4. Okay, right? Coming to the next question. Which of the following option is or are true? Option 1, you need to initialize parameters in PCA. Option 2, you don't need to initialize parameters in PCA. Option 3, PCA can be trapped into local minima problem. Option D, PCA cannot be trapped into local minima problem. Pause my video, try to think about the correct answer. Here I am explaining. Okay, So see, in PCA, there is nothing initialization parameter. Okay, right? No hyperparameter concept is there. So this option is correct. And see, in PCA there is nothing called local minimum question. Okay, it is not like some optimization problem, not like gradient descent. Okay, simple, straightforward, applied linear algebra is applied, which will ensure that you will be getting optimal solution each time. Same solution you will be getting. It is not at all like k-means, where number of cluster center initialization, based on that our output might vary, right? Always same answer will be getting. There is nothing like stuck in local minimum, right? So the option 4 is also correct. So the correct options are option 2 and option 4. That is option D. Okay, right? Coming to the next question. Which of the following offset do you consider in PCA? This one or this one? Okay. So see, options are vertical offset, perpendicular offset, both none of this. Now, pause my video, try to think about the correct answer. Here I am explaining. See, very simple. The correct answer is no doubt option B. This one is used when you are using linear regression to calculate the error. Okay, vertical offset. But in PCA, we are projecting our data on the principal component. So when you are projecting, we need to do like this, perpendicular to this projection. Okay, right? From the intuition itself, I hope you just recall the picture I have already discussed, right? So the perpendicular offset we need to consider option B. Okay, right. What are the optimal number of principal components in the figure? Okay, here it is basically storing cumulative proportion of variance explained, and this is principal component. Option A 7, option B 30, option C 40, option D cannot say. Pause my video, try to think about the correct answer here and explain. So basically, optimal number of principal component you need to choose such that it will capture maximum amount of variance, mostly like 99% variance, like I have shown you earlier in one example problem. Now see, in between 30 and 40, if you consider, after 30, if you are considering 30 principal components, if you are increasing the number of principal components, then also there is no much change in the amount of variance captured, right? So we can assume a good assumption as 30. So correct answer is option B, that is 30. Okay, right? And last question of our today's discussion. Which of the following can be first two principal component after applying PCA? These are the 4 options. Pause my video, try to think about the correct answer. Here I am explaining. Okay, no doubt the correct answer is option 3 and 4. Okay, how I am telling? See, that hint we need to apply here, that always the principal components are orthogonal to each other. Now if you just see, you just need to multiply and take sum and check whether you are getting result as 0 or not. Dot product 0 or not, that is the formula for orthogonality, right? 0.5 multiplied by 0.71, positive term, plus 0.5 multiplied by 0.71, again positive term, plus 0.5 multiplied by 0, that is 0, plus 0.5 multiplied by 0, that is 0. So basically you can understand that this result will not at all be 0. So these two are not orthogonal. This one, 0.5 multiplied by 0 will be 0, 0.5 multiplied by 0 will be 0, 0.5 multiplied by minus of 0.71 is some negative term, 0.5 multiplied by minus of 0.71 is some negative term, and when you are adding two negative terms, you will be getting negative term. As a result, this will also not be orthogonal. See, 0.5 multiplied by 0.5, that is basically here, I can write like this, 0.5 square. Okay, I am not simplifying. Then 0.5 multiplied by 0.5. Okay, plus of 0.5 square. Okay, then 0.5 multiplied by minus of 0.5. So what will be this? Minus of 0.5 square. Okay, and then here 0.5 multiplied by minus of 0.5. That is minus of 0.5 square. What will be the result? No doubt 0, right? So these two vectors are orthogonal. So there is a possibility that this can be first two principal components. So option 3 is correct. Similarly, in the same way, you can see that here all 4 are 0.5 and here 2 are 0.5, 2 are minus 0.5. So again, if you do individual multiplication and then take summation, that is dot product, you will be getting 0 for this one also. So the option 3 and 4 are orthogonal to each other. So option D is the correct one, right? So I hope you have understood this This is all for this video. If you enjoyed this particular video, please like, share and comment. Subscribe my channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of my latest videos. Thank you for watching.